My name is Judith Fischer, and I'm a master's student at the University of Haifa in Marine Technologies. This poster presents our work about computationally extended depth of field for microscopy on the go. We asked the question, how can we acquire microscopic images in a dynamic environment such as underwater? It is possible to acquire a single plane image, but it will have a very shallow depth of field. Acquiring a focal stack will result in motion blur due to the long acquisition time. One-shot imaging, where the focal stack is scanned during a single exposure, was suggested as a way to shorten acquisition. The one-shot image has to be deblurred in post-processing, and previous methods suggested simple deblurring based on restricting assumptions that led to a limited range. We suggest using a deep neural network for deblurring and show a 10-fold increase in the depth of field with a minor increase in the acquisition time. But what is a one-shot image? Let's start with a single plane, which is here the plane marked in our depth of field target on the right. A common method used to increase the depth of field is focal stacking. A focal stack is a sequence of images that is taken while moving the focus along the object, such that for each focal plane an image is taken. This results in a long acquisition time. Our goal is to image living organisms in situ. Then, acquiring a focal stack may result in motion blur. One-shot imaging tries to overcome this problem by acquiring the entire focal stack in a single exposure. The one-shot image is blurry since information from the layers is overlaid in one image. Therefore, post-processing is needed to deblur the one-shot image. Previous one-shot methods assumed a uniform blur and performed simple deblurring. This is a very limiting assumption, especially when aiming for a large depth of field. Over a large scanning range, the telecentricity starts to break, resulting in a depth-dependent PSF. We overcome this limitation using a deep neural network. In order to train the neural network, we simulated the point spread functions of the different focus planes of our imaging system with Zemax. For plane X, the PSF is a summation of the PSFs in the planes from 1 to X. The training dataset consists out of sharp images for each one of the planes and the blurred image using the simulated PSFs. This is a significant advantage as generating a large dataset with the real setup is very time-consuming. This is our optical setup for the lab and in the underwater microscope configuration. This scene was taken in situ in a LUT. Compared to the single plane, you can see the increase in the depth of field for our one-shot output. Here, motion blur is visible in the focal stack, which does not occur in our one-shot output. You can see more results on our poster. Thank you for your interest.